Welcome. Welcome to BSides Orlando 2025. Really excited to be here. My name is Harshad Kadam, and I'm the Senior Infrastructure Security Engineer at Indeed.com. Today, I'm going to present a project to you, which just three of my favorite areas: Zero Trust, AI Security, and Deception Engineering. The project is called MCP Threat Trap. It's a honeypot that lives at the Cloudflare edge. So today I'm going to actually show you how you can turn the MCP's trust assumptions into high fidelity security signals. This talk is going to take you on a journey. But before that, let me set the stage. So as you see, we will be talking about the AR reality, the problem today. Then we will talk about the real world. I'll talk about the blind spot in MCP. And then I will introduce what deception engineering is and how it fits into my solution. That will be followed with architecture and demo. And then I'll share the results in the white. And then we will go to why this matters for this ahead of us. So what's the problem we are really trying to solve over here? Enterprises today are wiring AI agents into their workflows. These agents can actually browse wikis. They can reset passwords and call APIs. And now with MCP and even A2A, this becomes quite easy and even more powerful because this gives you a standardized way of connecting these AI agents into your existing workflows, tools which you have in your enterprise. Now that's great, right? Really great for the productivity. But with this, it also creates a new attack surface. Now these agents don't question trust. If they see a tool over there, they will just call it. And the attackers and AI agents, with the help of MCP now, discover these internal tools very easily. The problem over here is now that the defenders are now buried in noise with no clear signal and the blind spots which go undetected. And that's just isn't just theoretical. Let's actually look at what's actually happening in the wild. Here are some real-world AI incidents which were recently published. At DEFCON 2025, researchers actually manipulated a customer service AI agent, and that basically helped them down the entire Salesforce record. That's again scary. Zenity Labs showed like you can use the customer AI agents, agent hijacking, and then you can use that for data exfiltration. The third one, Anthropic vibe hacking, that's actually a report. In that, it actually shows you how you can chain all these AI agents into carrying out attacks. And you can actually chain them into doing things from reconnaissance to actually doing exfiltration and extortion. So, and then the fourth one is the MCP Talks benchmark. In this, they actually show that you can do tool poisoning against 45 of the real MCP servers. And the success rate of the attack was more than 70%. Now, let me ask you, all of you, like how many of you are actually using MCP in your organization? That's great. Like I see some hand raising. Now, all that is really good because when developers are working on these things, they think of like, how can we bring in more productivity? But as a security team, it's always a challenging because you want to have innovation at the forefront, but you can't sacrifice the security of the company. So that's something we are going to be exploring over here. So where does this blind spot actually live? That's what we are trying to explore over here. As you can see over here, the AI agents over here, you will see the AI MCP tools. And basically, these are the tools which are listed over here. Now imagine there is a malicious tool, a plugin or an extension which gets inserted in this MCP tools. The AI agent won't question it. It will see your tool. It will say like, oh, this is a good tool. Let me see if I can check it out. As the human is not in the loop, it will just call it. And now the defenders are like buried in the noisy logs, which go undetected. So this is exactly the blind spot we are trying to explore over here. This is where like there is no identity, no trail. And then the gap which we see is from tool discovery to tool invocation and the noisy logs. So all this kind of form the operational blind spot, which security defenders are this stays buried into. So to tackle this blind spot, I thought about like, okay, what can you build which is low cost low maintenance, and something which you can easily integrate it into your workflows without affecting innovation. So to tackle this, I turned to deception engineering. Now, deception engineering is a very interesting field. I kind of got introduced to it very recently. Uh, I like to think of it as a Tom and Jerry. It's one of my favorite cartoons from 90s. That's the analogy I wanted to use over here because that's how I see deception engineering. Tom, our security team, is tired of chasing Jerry. So Jerry, unauthorized rogue AI agent, is our attacker in this case. So Tom, what he does, he plants a fake cheese, which is like an Okta admin password reset tool. This can be an IDP, any IDP tool or any tool which you can have in your toolkit. But I'm using Okta admin password reset over here. This is a fake trap. When Jerry being Jerry, he's very notorious for going after the cheese. He's going to go for this tool. When he sees the cheese, he's going to fall trap for it. So when he touches it, we get an alert through Canarytoken. And that is where we get like the signal, high fidelity signal, which can be really useful for security defenders to get started on the investigation. So all this is good, but how do we flip this advantage? The solution I have built is called MCP Threat Trap. It's basically a serverless honeypot that lives on the Cloudflare workers. For folks who don't know Cloudflare, it's like it's a vendor basically, and they offer a product called Cloudflare Worker, which is a free compute server which you can deploy at the edge. It's globally scalable. They kind of give you 100 workers, which can be used for building different traps, and you can also use it for the developer activities. So this Cloudflare Worker, you can actually configure as a remote MCP server. And with that, you can actually simulate real internal tools on this honeypot. This is the first piece of the puzzle. The second piece we are adding over here is the things like Canarytokens, which is again free tokens, which you get. You can easily integrate this into your honeypot, and you can use it for the silent detection. And now, because we have built the logic for MCP and A2A into our workflows, you can actually use this for AI-aware deception. So apart from humans interacting with this will also catch the MCP and A2A attack behaviors, which will be interacting with your honeypot. So let me show you how MCP Threat Trap works in the action. This is how the worker looks like. As you can see, that is my Cloudflare worker, which is also configured as a remote MCP server. Now an AI agent or attacker will connect to it. I've exposed 3 tools over here. Out of this, 2 tools are real tools. The 2 real tools are going to give you data based on my resume, GitHub, and the custom data which I have fed into it. And the third tool is actually Canarytoken. Now, what happens is but here is the catch. When an AI agent or attacker will interact with this. So when it interacts with the real tools, it will get the real data. But when it's interacting with the fake tool, it's not going to do anything. It's just a trap. So what it's going to do is it's going to log the metadata. That metadata is going to contain the IP, username, user agent. That can be really useful for like early stage reconnaissance. And you can actually start investigating where the attacker is. So let me actually show you this in action. This is where the fun part begins. So this is my Cloudflare worker website. As you can see, this is my honeypot. It's active. Now this is the security monitoring is turned on. I have exposed 3 tools. I have specifically mentioned that welcome, ask about me, admin password. Now you can test this honeypot through my terminal using curl, or you can also launch it to MCP client or AI agent in your scenario where you can connect to it. Now over here, this is my AI playground, which is also acting as an MCP client. I'm going to put my URL over there for my worker node. Once I'm connected, you will see the list of tools over here. Welcome, ask about me, Okta, password reset. You can also configure authentication and authorization. So this is not public and you can make it more private. So that way, like, you're catching the attackers within your infrastructure once the attacker is within your environment and not on the public internet. So that's something you can easily configure. So these are some models, how you can interact with this. Exactly like how AI agents are kind of used as a chatbot these days. Now, let's see what happens when we use a welcome tool. I'm saying hello. Now it's going to give me, like, it's my assistant. It's going to give me answers. You can try all these tools which are available on my MCP report. This is a simulated tool. Let's see the magic, what happens. Wait a minute, not so quick. So let's actually see if we can reply to my real tool first. So can you tell me about my skills? And once I enter that, it's going to fetch the data from my resume and GitHub data, exactly like how racks are configured these days. And then you will be getting the key skills over here, like cloud security. All this is kind of custom data that you can feed into it. Now let's actually see if the trap is working. Now I've tried to make it more realistic. So for like the sensitive usernames as well as for something which can be a normal user. So I'll try to reset password for user admin. It was flag sensitive and the message I got is very different. It looks very realistic for someone like an attacker. You got a reference ID. It was flagged as sensitive. So attacker thinks he might have got something really good to play around with now. Now he's going to try and reset the password for me. As you see, the message is different. Again, the response is different. A recovery email has been sent. The user will need to complete identity to password. So you get a realistic response as if like, attacker feels like, yeah, I've got hold of a tool. But behind the scenes, nothing was triggered. No password reset was initiated, but the canary token was triggered and we got the metadata from here with the user agent and all the useful information like username used, the client, the tool which was invoked, and then the geo info and the source IP. Same thing. The second alert was again the same one, but the username is different. The MCP client is different. So we got the source IP for this one as well, and the geo info. Now that you've seen the how the canary token is getting created, let me actually show you how the Cloudflare worker was configured. So if you go into my Cloudflare account, this is the domain I'm using. But like if you navigate through the worker node, these are some other projects which I'm working on, but this is the reception remote MCP server. Now, if you see there is request and sub request, so it doesn't just tell you if it's a normal scanning. If an attacker is actually interacting, that's when you get the sub request. And you also see the request distribution coming from different geographies. But when you compare this with the things like Canarytokens, you can correlate those logs to actually see the trail of like how attacker actually carried out the data. And this is something which is observed in the observability platform of the Cloudflare, where you actually see like how the attacker used the tools and how the honeypot was triggered. So you get like a trail of logs which you can use against for the forensic purposes. Now, apart from having advanced canary token creation, I want to make sure that my honeypot doesn't get DDoS. So I have rate limiting configured, have sensitive username detection. There is realistic response delays configured as well, like a 5-minute interval. So the honeypot doesn't get like blasted with the attacks. And then I have support for MCP and SSE as well, so that it can handle both human as well as AI agent interaction with it. This is the code base I use for it. These are my constants which I use. This is pretty basic. And then this is actually the law. It's very simple. Like anyone can actually build custom tools the way they want it and try to expose something which is not like, which is realistic to their environments, but actually makes attacker feel like, oh, they got something really good. So as you can see, I have created minimal data info because I'm using the free version of the Canarytokens. So you can have only minimal info in your headers. So that's something I used over here. I'm introducing the realistic delay. And then as you saw, like we are having different messages for different responses. So attacker feels like, like it's actually giving me a real response in the real system. So yeah, that's MCP Threat Trap. That's the honeypot. And you can actually build your own custom version of it very easily by just cloning it. So let me, so all this is good. As you are seeing the demo now. So these are some results in the wild. I can't actually share the exact threat intel which I got, but what I can say, this project basically started as a POC because I wanted to study the AI agent attack behaviors. But within first week itself, I got my first hit, which was from a scanning campaign. So this project, which started as a POC, turned into a real proof of value for getting that early threat intelligence. Now, over the course of months, I found a lot of attacks coming from different geographies. When I correlated those IPs in the abuse IPDB, some of those IPs were not reported before. And that actually showed me some early threat intelligence, which was not available. And I was able to report that very easily. So when I think of it like this, so that was my hypothesis when I started this experiment. And that just proved that, deception works really well for AI agents as it does for human attackers as well. So, but why does this really matter for enterprises? As I think about it, we don't want to just put this as a POC. We want to also think of how you can implement the honeypot like this in your infrastructure. Now, the traditional honeypots have always been something where you need to have real infra. It can cost you money. And again, like this is something you want to make sure that you're not really exposing real assets of your company. So this honeypot, as I said, like it extends our visibility and threat intelligence, giving us some early threat intelligence into MCP behavior. Because this is built on the Cloudflare workers, you're not really exposing anything. This is less and globally scalable. You don't require any EC2 patching or any infra for this. I like to call it security always on at the edge. Unlike other honeypots, this is like the first of its kind. It's a low noise honeypot. No one should be interacting with. As I showed you from the request and the sub request page, when you see sub request, that's when actually the attacker is actually interacting with your honeypot. And it's not just the normal scanning campaign which is happening. So any recurrences and misuse attempts can be easily catched with this honeypot. Now, if you actually integrate this with like a MCP gateway in your infrastructure, this can become like something which can become a guardrail for your private environment within your infrastructure and not just public. And the last one, this is a passive guardrail for AI adoption. So when I think of developers working in the organization, you don't want to affect their productivity and you want to have security as well. So this is where you can just put this because anyone shouldn't know about this. But if anyone touches them, we know it's a near perfect signal. And that is where you can get started on the investigation. Now looking ahead, things like Canarytoken offers many such tokens. I've already started experimenting with some of this. The QR token, the config token, which can be into your Kubernetes cluster, AWS keys, again, a really good tool to kind of have in your toolkit. So this is where it will be evolving. I'm developing this as a deception as a framework using other Canary tokens. Now, the second thing is like it can be easily integrated into your zero trust infrastructure. I talked about the MCP gateway before. Cloudflare, again, like I don't want to kind of give you a specific technology, but this can be integrated with any internal MCP gateway you're building. But again, something Cloudflare offers is like a server portal. So this can be put into that as a deception framework for that. And the signals you will be getting, you can actually manage real and fake tools easily without like side by side, putting that into Cloudflare. And then this is open source. This is my GitHub repo for anyone to deploy improvements. You can easily fork it, build your own tools, and put it in your organization without you exposing your real infrastructure. So if AI agents and MCP is going to be the way that your agents are going to interact with your internal tools and workflows, then some of those tools should be apps of your own design. That's what I feel as a security team member. So hoping you can actually build this. And this is MCP Threat Trap. And I would really like to hear your thoughts and ideas. Thank you.